Ellipses.
8.2 notes.
You caught me right after I took a bite of apple. I'm so sorry.
I do that all the time. All right, so an ellipse is a set of all points of planes whose distances from two fixed points of the plane have a constant sum. So those are going to be our foci,
Right.
which is plural of focus.
Right.
And it's real. I don't know how you pronounce it for sure. I like to say foci.
I do this. I use both.
Yeah, so that's a tough one, but just as long as you get your point across, and it's not focuses.
Yeah, don't say focus. That's not what it is.
Okay, so if you take the distance, but like if you have your two foci and like you draw to a point, at any point, if you add those distances together, they should be the same thing.
Wow.
So that's kind of a neat concept.
You could do an ellipse with a piece of string, right? And two tacks.
And two pieces of you're right.
Take a piece of string.
Yeah, you would put two tacks down.
Right.
And wrap the string around, and then put your pencil at where it's the tightest.
Right.
And then just make it draw in an elliptic fashion.
It's kind of a cool thing.
That is kind of a cool thing. So some more vocabulary. The line through the foci is the focal axis.
That's an important one to remember too.
Yes. The point on the focal axis midway between the foci is the center, which, I mean, it's usually pretty obvious what the center is.
The center is the center.
Yeah. The points where the ellipse intersects its axis are the vertices, and so whichever one's the focal axis is actually is it the longer one normally, right? That's the focal axis, is the way that it's longer.
Yes, yeah, the focal axis has to be longer with the ellipse.
And so the vertices are the points at the end of the ellipse.
Right.
On the long,
which would also, we
direction.
could also call it the major axis, as it were.
Right. The major axis is the longer axis. The minor axis is the shorter axis.
And you might see also in texts where the other part of your ellipse, not the major, but the other smaller distance from center to the point on the curve, sometimes is referred to as a minor vertex.
A minor vertex. Oh, okay. Yeah. So that you have vertices, and then the other direction you'd have minor vertices.
Or sometimes co-vertices or something like that.
Okay, that makes sense. So we have a box and an example of what an ellipse looks like on our notes. And so this box, just like the boxes for parabola, are going to be super helpful for our problems.
Super helpful to the infinity power.
Right. So the only difference between these, and this is really just kind of, just to specify a little bit of a difference here, is that basically A is going to be the bigger axis. So A is going to be greater than B.
Every single time with an ellipse. Period. End of story.
Right. So they may not actually, in the book or while we're doing stuff, we may not actually write y squared first ever, but addition is commutative.
Right. So you could write it
in either order. Mm-hmm. And so this second column here is where the bigger number is underneath the y.
Right.
And so that's what's going to make this case happen, which would give us an ellipse that is skinnier.
Right.
It's looks like a cucumber, perhaps.
Right.
All right, so how about on example one, let's find the vertices and the foci of the given ellipse.
So first off, please notice that for an ellipse, you have to equal 1.
Yep, that would be standard form. So how do I change a 36 to a 1?
You divide by 36.
Brilliant. So if we divide one thing by 36, we got to do it to everything.
Yeah, that's totes brilliant, by the way.
Thanks. Yeah. And so this may look challenging to simplify, but I like to think of it as 36 divided by 4 gives us 9 on bottom.
Right.
And for the most part, that will work out. Every now and then you'll end up with a fraction on the bottom, which is uncomfortable, but it can happen.
And we'll probably discuss how to deal with the fraction on the bottom.
Hopefully.
Yeah.
Hopefully. So this is a case where the x has the bigger number underneath. So this is the first column.
The A is 3.
So the A is 3.
Why is it 3? Because you have to take the square root of the 9.
Because this is actually A squared.
Right.
And so B here would be 2.
Right.
Okay, and then what's important here is a Pythagorean relation for this, which we all know the Pythagorean theorem, but for ellipses, we instead of adding a squared plus b squared, we have to subtract a squared minus b squared, and that will give us c squared. And c is like a special helpful number for the foci, basically.
Yes, it tells you, c actually will tell you how far from the center of your ellipse the focal points are to be located. So
right.
Square root of 5, although not a a number I carry around in my back pocket, I know about where that is.
It's somewhere between 2 and 3?
Yes.
So our vertices, if we look at our chart over here, our vertices are at plus or minus a comma 0. A is 3, so
Plus
they're
or
at
minus 3.
plus or minus 3
And
comma
0.
0. Our foci,
Are plus or minus the c part then.
right, so plus or minus c means we'll have
Plus or minus the square root of 5.
comma 0. And the important thing is that because the bigger number was under x, that's where we stuck these values was with
Right.
x. If the bigger number had been with y,
Then
we
you
would
can
have put it
put
with
them all
y.
with y. Yep.
So,
The center of this guy, BT dubs,
uh-huh,
is at the origin.
yes. at
Because we're not
0,
adding or subtracting anything
to our
to
x and
x1.
y's. Yeah. All right, example 2. Find an equation of an ellipse with foci 0, negative 3 and 0, 3, whose minor axis has a length of 4. Sketch the ellipse and support your sketch with a
I
graph.
already know what B and C are. I can tell you right away without doing any math.
Okay, and why don't you also tell us your thought process there for finding B and C?
Well, here's the deal. If for finding C, that's the distance from the center to the focus. So if I go 3 one direction and 3 another from the origin, then my C value would have to be 3 because the sign changed. So I just went from positive 3 to negative 3.
Absolutely. So this is a plus or minus C
Right.
situation.
Right. Plus
so
or minus C.
that means C is 3.
Yeah.
Now how about B?
B then, if I know that, that must have been my spelling there. That linked. That's
Yeah.
got to be a Scott Hazelwood oopsie there.
Whoops.
So if the minor axis is just 4 units long,
Uh-huh.
then that would be half of that. Then would be the B value because the distance from the center to that co-vertex, that minor vertex, is 2.
That's right. So B would have to be 2.
Take a picture of the picture.
Yeah, so I
That's a
can
bummer.
fix that.
All right.
All right, so B would be 2 because if it has minor, that's twice as long as the length of our semi-minor, which is
Right.
what B
Right.
is, right? So we had to divide that by 2. So we know what C and B are. The other things we'll need for an equation are A. Actually, it's the
yeah.
only other thing we need. So we use
That's
this
the only other
Pythagorean relationship, A squared minus B squared equals C squared. So I'm adding 2 squared over so that I get 9 plus 4, which is 13. And if I square root both sides, that gives me A equals,
Plus or minus the square root of 13. Now, I know the square root of 13 can be a little bit of a sticky, tricky thing.
well,
So,
it's between 3
you
and
just,
4.
You just have to figure out, 9 is the square root that we know to be 3. 16 is the square root we know to be 4. So we're right in between those.
That's right.
So
Now we're set up to do our equation, and no matter which one is the bigger axis, typically we do write x squared first. But A, which is the square root of 13, which is our bigger thing, has to be underneath y because of the way our foci is
right.
written.
Wherever the focal numbers go, that's where your A's and B's, that's where your A needs to go.
Right, and so our a squared, which would go underneath y, is square root of 13 squared, which is 13. Right, so we
Right.
technically really only needed to solve for a squared,
Right.
which was 13.
But when we graph it, we'll need that square root part.
Right, so b goes underneath x, 2 squared is 4, and so that right there
There's
is
your
our
equation.
answer. Now, I think graphing ellipses is pretty simple,
I agree with you.
okay? And so you just make your x and y axis, and you draw some lines.
And we're centered at the origin on this one,
Right.
so that always helps.
And so here's what you do is you go left and right
2 units.
2 units because that's the square root of 4. So I make a mark to the left and to the right 2 to start me off, and then we're going to go up and down somewhere between 3 and 4. So
A little bit closer to 4 than to 3, but not much. No, not that close.
Oh, hush.
Oh, no.
and then you connect them in an elliptical fashion,
Sort of like an American football,
or like
an
an
oval.
Easter egg kind of ish. There's lots of things you could pretend that that's the shape of. But
That's a
there's
really
our
good
ellipse.
ellipse, by
Well,
the way.
thank you.
Yeah.
I've been practicing.
I can tell.
Thanks.